Anyhow, good morning, everybody. So, as we know, till now we studied what is gravitational force and what is Kepler's laws, and as well as what is universal law of gravitation, or else we can say Newton's universal law of gravitation. So, these are all the things we discussed from last week. So, now today's class we are going to see what is the importance of this universal law of gravitation, and after that, in last class, I told you the characteristics of G. Do you remember, Mr. Harish, Mitakshri? I told you the G values, what is the properties of or characteristics of capital G. I think everybody is remember?
Yes, sir.
Yeah, how it
Yes,
will
sir.
be.
Yes, sir.
That is what, and also I taught you that what is inverse square rule, how the Newton is guessed the inverse square rule and all. Do you remember that, everybody?
Yes,
Yeah.
sir.
Yes, sir.
And all you should learn Kepler's third law, how it will helpful to Newton's to derive the universal law of gravitation. That is all you should remember. Now you can see here. Let us come to the all of you take your Ncrt and you will be there. Page number 134. You'll be having one more to know factor. So let us see that factor first. That is what you all people knows, that inverse square rule. What is inverse square rule? Can anybody tell me what is inverse square rule? Please let me know, all of you. First of all, what is inverse square rule? Anybody? Inverse square law. Force is inversely proportional to square of distance between them. Do you understand, everybody? So this is what we used to call as inverse square law. Yes or no? Please respond.
Yes, sir.
sir.
Yes. So
Yes,
now
sir.
there they have given one fact that more to know. Can you read, Mitakshri, that inverse square? They have given more to know, second box, page number 134. Can you read that? Saying that force is inversely proportional to the square of D. D means they have taken D, but what we have taken? We have taken what? R. So force is inversely proportional to distance between them. Either R or D, doesn't matter. What does it mean? For example, if we'll take, if D or R gets bigger by a factor of 6, means in the sense of the distance between the objects is increases 6 times, then the force will decrease by how many times? Force will be decreased by how many times? 6 times increases. The distance between them or we can say D is increases by 6 times. Then what about the force, guys? It will be decreased by how many times?
1 by 6 times, sir.
Yeah, 1 by 6 square. So which is equals to how many times it will decreases? 6 square means
1 by 36.
how much? 1 by 36. So the force becomes smaller. How many times smaller? 1 by 36 times smaller. Do you understand? So that is what inverse square rule. So if, for example, if the distance between the objects R become 2R, double, then force will be decreased how many times, guys? Anybody can tell me? Force will become how many times? It will decreases. How many times it is decreases? Nobody will answer. R double it will become. Double means what? In place of R, we can write 2R square. So that how many times it is decreases, Mitakshri? 4 times. 4 times. 1 by 4 times smaller than the normal force which is existed. Are you understand, Mr. Hari? Gokul? How it will be?
Yes, sir.
Yes, everybody. So that is what only we used to called as inverse square law. So if the distance become double, then force decreases 4 times. If distance increases 6 times, then the force decreases how many times? Force is decreases 1 by 36 times. Understand? For example, distance between the objects increases 3 times. 3 times increases. Then what about the force, guys? Anybody? Force decreases by how many times? Force decreases by how many times? Anyone? Open your mouth here. What is this? Force will decrease by how many times, Mr. Akilan?
So 1 by 9 times.
1 by 9 times smaller. Understanding? So that is what it is. So 1 by 9 times smaller than the actual force. That is what you should understand. So this is only called as inverse square. Now, let us come to the today's class. As we know that we are going to study the next one. Next concept is called as importance of the universal law of gravitation. So all of you please keep heading. Importance of universal law of gravitation. So as we know that, can anybody tell me what is the universal law of gravitation formula, please? Force F is equals to, try to open your mind.
Capital
Force
G.
F is equals to capital G into, as we know that, M1 into M2. Hey, if you're not speaking, please leave from the meeting. No issues. I don't care anybody. So F is equals to, what is the formula, Hari? Capital G into M1 into M2 divided by R square. So M1 into M2 is what? Masses of two bodies. And R means what, Mitaksri? R means what?
Sir, distance between those two bodies, sir.
Understand? So now observe very carefully here. So what is the importance of this one? As we know that capital G, what is the G means? Capital G means, what is the capital G?
Universal
Universal
gravitation.
gravitational constant.
Gravitational constant. So remember class 10th, again electricity also, similar universal law of gravitation. The similar law will come in electricity. That is what we can say Charles law. So sorry, Coulomb's law. So by the time again you should remember this concept. That is why please learn it very carefully. Coulomb's law in class 10th, electricity will come similar to that. By the time we'll consider charges. Okay. So G value, as we know, universal gravitational constant. Universal gravitational constant. So as we know, what is the value of that one? Everybody. G is equals to 6.67 into 10 power minus 7 Newton square meter per what? Newton square meter per kilogram square. That is the value of capital G, which all people studied already. So this is the constant. So Akilan, who has given this value? Who has derived this value? Mr. Gokul?
Henry Cavendish.
Arun Kailash? Yes, please. Who has been
Henry Cavendish.
Henry Cavendish. Understand? So now let us come to here importance of universal law of gravitation. As we know, this law is not applicable to only Earth and the objects of the Earth. Oh, it is applicable to throughout the universe. So as we know, we can use this law. The first importance is we can calculate the force that binds us to the Earth. That is the important. Understand? So how the objects are, every object, whatever the object is throwing upwards, it is falling again towards the home, guys. It is falling towards the home. Whatever the object I will throw, it will fall towards the home.
The ground, sir.
It will fall to the ground. So what is the force present? How much force is present to bind us to the Earth? We can calculate with the help of this universal law of gravitation. So please all of you make it. The first point, the force that binds us to the Earth. We can calculate the force that binds us to the Earth. That is the importance of, we can calculate the force that binds us to the Earth. That is the first importance. Second importance, is it applicable only to the Earth and the object or out of space also, out of Earth also? Yes, please. Is it applicable only Earth and inside the Earth or out of Earth also?
Out of Earth also, sir.
Throughout the universe. Is it yes or no? So that is why we can say, we can find the motion of the moon around the Earth. That is the second important. What we can do, guys? Motion of the moon, not only moon, all the satellites and artificial satellites, natural satellites, everything. Motion of the moon around the Earth, we people can observe with the help of this universal law of gravitation. Importance. Next one, we can find the motion of the planets. So planets are surrounding on whom, guys? Around the whom? Motion of the planets around the whom? Motion of
Around
the
sun, sir.
planets around the whom? Motion of the planets around the sun. Okay, so this also we can analyze. So how the planets are moving, how they are doing. These all the things we people can find, and we can use with the help of this one. We can find the distance between the any planet, any object in the world. Do you understand, everybody? So what is the objects, where they are present, what is the force acting between them, how much force is acting, and how they are behaving. Everything we can analyze with the help of what law? With the help of what law, guys? With the help of universal law of
Gravitation.
gravitation. Understand, everybody? Next, you all people know, if you visit the near the ocean or beach or whatever it is, sea, you all people see that always the water will come forward and go backward. We used to call something. What is that called? Anybody? What is that
Wave,
called
sir.
as name?
Waves.
Yes, we used to call it as what? The water coming
Waves.
forward and going back. What is that called as, everybody? We can say
Waves.
tide. Understand? Very good, Akilan. So tides. So actually, the formation of tides is causing due to moon and sun gravity. Moon and whose gravity? Sun's gravity
And
only causing for formation of tides on the earth. Understand, everyone? So the tides due to the moon and the sun, we can analyze with the help of how the tides are forming. The tides due to the whom, guys? Due to the moon and the sun. Due to the moon and the sun. So because of moon and sun's gravity, or we can say gravitational force or force of gravity, whatever it is, force of gravity, it is causing to form the, what it is causing? It is causing to form the tides. So that is what, so that is also we can analyze with the help of universal law of gravitation only. How the tides are forming, what is the phenomena behind, what is the principle behind the tides, everything we people can study with the help of universal law of gravitation. It might become for even 2 mark question. So what is the importance of universal law of gravitation? Then you have to remember, first of all, universal law of gravitation, F is equals to force of gravitation, F is equals to capital G into M1 into M2 divided by R square. What is our Ncrt formula? Anybody can tell me? What is our Ncrt formula? According to Ncrt, what we can take? Capital G into capital M into small m divided by D square. Both are same only. Please remember. M1 capital M, mass of body 1. M1, M2 and small m, mass of body 2. And what do you mean by D, guys? DRR. Mr. Arun Kailas. DRR. What do you mean by that? DRR. Yes, anybody? Will open, will never open your mouth, Ra? Yes, please respond.
yes, sir.
Yes. So what do you mean by R?
Yes, sir.
D? What do you mean by R or D? The distance between
Distance.
two objects,
Two
from
objects.
their centers. Distance between the two objects from their centers is only called as DRR. That is what. So these are the 4 points where the importance of universal law of gravitation we people usually will study. Is it okay, Omar? Neha? Mitakshri?
Yes, sir.
Is what? So we can find the force. What is the force binding to the earth? Not only that, any kind of objects, we can calculate the force which is binding, understanding, and we can find the distance between the moon and the earth, and as well as the planets around the sun. What is their motion, how they are behaving, everything we can analyze with the help of universal law of gravitation. And the formation of tides, how the tides are forming due to the gravity of earth and gravitational force of moon and the sun, everything we'll study with the help of this law. That is what? Universal law of gravitation. Is it okay, guys? Everybody? Yes?
Yes, sir.
That is what. Now, Let us get back to the next concept. If I hope you all understand, please write that 4 points. So if you'll understand that, then we'll move to the next concept, which you are very familiar already. So that is what we'll study now once again, and we'll go back to that. So if you want to study that concept, you must have the knowledge of first 2 chapters. So let me check it. How many of you are having? So let me say that all of you, as we all studied that when any object is thrown upwards, what is the initial velocity? Anybody can tell me? When any object is thrown upwards, yes, initial velocity is maximum. So as we know, after reaching to the certain height, what is the final velocity? Final velocity.
Zero, sir.
Zero. Now it is against to the gravity or towards to the gravity? Against to what? Against to acceleration due to gravity. Acceleration due to gravity. So that it is negative or positive, we people will take.
Negative.
Negative.
Do you remember, everybody? This is what for thrown upwards. Thrown upwards. Do you understand, all of you? Now, if it is freely falling, if it is falling down, that is what we can say freely falling, or we can say free fall. So then what is the initial velocity? Initial velocity is
Zero.
up.
Zero, sir.
Before touching the ground, what is that? Velocity is equals to maximum.
Maximum.
You understand, all of you? Now, is it towards to the acceleration due to gravity or opposite against to the acceleration due to gravity? Towards to that. So it is falling towards to the earth. So that is why G is positive or negative?
Positive.
G is positive. Very good. Do you all remember these things? Any doubt? Please let me know. Are you clear, guys?
No, sir.
No. Now, observe very carefully one more thing. Newton's second law. I want Newton's second law. What is Newton's second law? Newton's second laws. Newton's second law. What is Newton's second law? Second chapter we studied. Force F is equals to mass into
Acceleration.
acceleration due to, understanding, that is what acceleration of a body. So force F is equals to mass into acceleration. Now what we are going to study, it is completely related to these 2 concepts. That is what you must understand this concept, and as well as you have to remember this one. Then only it is possible to study the next concept. That is what it is called as small g. So small g means the gravitation force. That is what is the gravitational acceleration due to gravity, and what is the difference between capital G and small g, we will study now. So that is what the entire concept name called as free fall. What is the next concept we are going to study?
Free fall.
Free fall. Do you understand, all of you? Free fall. So what do you mean by free fall and how it will be behaves an object? Let us understand. Now, first of all, free fall of all of you observe. Now, if any kind of object, if any object is falling towards to the ground, understanding, freely, without any external force. Understand, Mitaksri? Without any external force, if any object is falling freely without any external force, then we can say that object is said to be, then the object is said to be in what? Object is in free fall. Do you understand, everybody? Please respond. If any object is falling towards to, understanding, downwards without any external force, then we can say that object is said to be in what, guys? That object is said to be in what?
Free fall.
Free fall. No external force is acting. Whenever the objects fall towards to the what? Towards to the earth, under this force alone. Which force? Only gravitational force. Only which force should act? Only which force should act? Only gravitational force alone must be there. Other than that, no other external force should act. then we can say the body is said to be free fall. Any kind of object freely without any falling freely without an external force, only which force must be acting? Only which force must be acting? Gravitational force, and it is falling towards the water, towards to whom?
Ground.
To earth. Understand? Then we can say that object is said to be in free fall. Any object falling towards to the ground only under the presence of gravitational force and no other external force is applied, then we can say that object is said to be in what, guys? That object is said to be in what?
Free fall.
Fall.
Free fall. Then in this case, what is the Newton's second law? Can anybody tell me? As I told that when the object is moving like this, we can say acceleration. But when the object is falling freely, then what is the acceleration? A is equals to what, Mitakshri, Harish? Acceleration is equals to what? A is equals to, consider C. That is what we can say, gravity. Do you understanding? Acceleration due to gravity. What do we to call, guys? Acceleration due to gravity. Are you understand, everybody? So then what is the formula will be modified according to the Newton's second law? The force acting between them, F is equals to M into A. But in this case, F is equals to what it will turns? Anybody can tell me? F is equals to M into G. So let me consider this is what equation number 1. Any doubt, guys? Any doubt? Yes, please.
No, sir.
Any object is falling towards the ground, then what is the force acting between them? What is the force acting? The force exerting is equals to acceleration due to gravitational force, F is equals to M into G. So let me consider this is the equation 1. Any doubt, guys? Yes, please. Respond. All of you. So if any object is falling freely towards the ground, then the accelerating force which is falling towards the ground, the force which is equals to what? Mass into acceleration due to gravity. Is it okay, Hari? Yes, please. So the body is falling under the only one force. What is that force? The body is falling under only one force. What is that, guys? What is that force? What is the use of gravitational force? Only the body is falling under the gravitational force. Is there any external forces existed?
No, sir.
No external force. Then the body is said to be in what? Free fall case. So at this case, the force F is equals to, from the Newton's second law, force F is equals to mass into gravity. Now, we know that what is the universal law of gravitation? Force of attraction, gravitational force of attraction. What is the formula? Anybody? We know that gravitational force of attraction. Anybody can tell me what is that? Between two bodies, guys. Between two bodies, what is the force of attraction? Gravitational force of attraction.
C into M1 into M2 by R square.
Capital M into small m divided by R square. Can I take it, Mitakshri? Let it be. Understand?
Yes,
Capital
sir.
M into small m divided by R square. Any doubt? All of you? Now this is what it is, equation number 2. Now equate equation 1 and 2. Equate equation 1 and 2. Then what will happen? Anybody can tell me? See there. F is equals to M into G and F is equals to G into M divided by R square. Now both can I equate? Then what will happen? If F is equals to F, LHS is equals to LHS, then what will happen? RHS is equals to RHS. So if I'll equate this, then you can see that what will happen? Equation, you should speak, I should not speak. FF will get cancelled. So MG is equals to, what will happen? Capital G into small m into capital M. Sorry, capital M into small m. Capital M into small m divided by what, guys?
R square.
Divided by what? r square. So now both the sides something is similar. Can you see that? What is that? Something is similar. Mr. Arun Kailash, what is similar in both the sides? Open your mouth, man. Why are you attending the class then? What is the similar, guys? Both the sides, something is similar. Neha, Akilan, small m and small m is present. Both will get cancelled. Then what is G? G is equals to what? Anybody can tell me? G is equal
G into capital M.
capital G into capital M divided by R square. So this is only called as gravitational force. G is equals to small g is equals to capital G into capital M divided by R square. What do you mean by capital M? Mass of body 1. Mass of body 1. That is what it is. So this is the small g formula. Are you understand, Mitaksri? So small g is equals to what? Small g is equals to
Capital G into capital M divided by R square.
capital M divided by R square. Any doubt anybody can ask or else solve. So this is what G. So which is known as, what is G? Gravitation. Understanding? Acceleration due to gravity. That is what G means. All of you note it down. Acceleration due to gravity. So what is the formula? Acceleration due to gravity. G is equals to acceleration due to gravity. In case of what? In case of what case, guys? In case of what? Free fall. Then G is equals to capital G into capital M divided by R square. Is it okay, Rama? Say yes or not, list, Mr. Gokul.
Yes, sir.
Yes. That is
sir.
now. This is what between two bodies. So we can say, suppose this is the one body and this is the another body. So now this body is falling towards to this body. Now this body mass is capital M, this body mass is small m, and the distance between them is what? R square. Then at what force, at what acceleration this body is falling towards to this body, then we can use which formula to calculate? Capital small g is equals to capital G into capital M divided by R square. Is it okay, guys? Is it okay, guys? Everybody? Yes? All of you? Now, if Earth is the mass of object body 1, if Earth is the body 1 and any other object, any object is body 2, any object is considered as body 2. Let me consider who is in bigger in size. For example, Harish is dropping a stone from certain height. Stone. This is the stone and this is the earth. This is the earth. Now, you tell me who is bigger, guys? Earth or stone? Earth or stone?
Earth, sir.
Understanding? Now, as we know, let me consider mass of the earth is capital M and mass of the stone is what? Mass of the stone is what? Small m. Are you understand, everybody? Now, the distance between their centers, what we used to call as? R, or we can say small d. Now, as it is, remember, the mass of the stone is at least, is it any 1% of mass of the earth or completely negligible? Very, very small, extremely small. Yes or no? Yes or no, guys? Nobody will
Yes,
respond.
sir.
Yes. So mass of the stone is mass and size of the stone. Size of the stone is negligible. Do you understand, Hari? Negligible. So the distance between their centers, which we will consider equals to radius of the earth. Do you understand, Hari, what I'm saying? Mr. Gokul, Mitaksri, I'm considering, as it is, stone is very, very small in size. So the distance between the earth and the small object, a stone, is I'm considering as a what? Radius of the earth itself. So radius of earth is the distance between the a small object and the earth. As it is, earth is considered extremely large in size. Then what is the G formula? Anybody can tell me? G is equals to, what is the formula? Gravitational force, the force of attraction. Tell me, guys, acceleration due to gravity, G is equals to capital M. M means what, guys? Anybody can tell? Mass of
Earth.
Earth divided by, now instead of small r, what r will come? What r will come?
Capital.
Capital R square. So this is what the formula for calculating gravitational acceleration due to gravity of Earth. So I can say here GE. What do you mean by GE, Mitakshri? Acceleration due to gravity. Understanding? Acceleration due to gravity of Earth. Acceleration due to gravity of Earth is equals to capital G into capital M. Capital M means what? Mass of Earth divided by radius of Earth square is only called as gravitational force of Earth. Is it okay, Ra? Yes, please respond. Now, if I want to find gravitational force of moon, can you tell me, anybody, what is the formula now? Gravitational force of moon. Anyone? Gravitational force of moon. Yes, please. What will come? Capital G into mass of moon divided by radius of moon square. Is it okay, Mitakshri? Now I want to find gravitational force of attraction of sun. Anybody can tell me what is the formula? Sun. Gravitational force of sun.
Capital G.
Into mass of sun divided by what will come? Radius of sun square. Is it okay, ma? Please open your mouth. That is what the formula which we can use for calculating acceleration due to gravity of every object in the universe. Understand? Now, the main thing for every body other than Earth, for Earth alone we used to say gravity. G means gravity. Do you understand? As we are living on the Earth, G means Earth. Understanding? Gravity, we can use the word only for the gravitational force of Earth. All of you should remember. So gravitational force of acceleration due to gravity, or gravity we can say, only for Earth we can say gravity, and other than Earth, remaining all the bodies, we used to word called as gravitational force. We should not use a word called as gravity. For Earth alone, we can use gravity or gravitational force. Both are same. But other than Earth, all the objects we should use what word? Hari? We have to use only gravitational force. For Earth alone, we can use a word either gravitational force or we can say gravity. Both are same only. Is it okay, guys? Mr. Akilan, Arun Kailash, Gokul. For Earth alone, we have to use a word called as gravity, or commonly we can use a word called as gravitational force. So whatever it is, you can use it. So, but Earth, you have to use only gravity or gravitational force. Other planets, we cannot say gravity of sun. We have to use what? Gravitational force of sun. Understand? That is, you should remember. For Earth, we can say gravity of Earth. But moon, gravitational force of moon. Sun, gravitational force of sun. Jupiter, gravitational force of Jupiter. Mars, gravitational force of Mars. That is what you should remember. Is it okay, guys? Yes, please.
Yes.
That is what. So now, what is the Earth gravity? Anybody can tell me? What is the Earth acceleration due to gravity? What is the Earth acceleration due to gravity? We all people knows that value already. What is that?
Capital G into
Formula, not value I am asking. 9.8 meter per second square, or I told you rounding off. What is that, Mitakshri? Numericals and all we used. 10 meter.
10 meter per second square.
Understanding? For throwing up, we consider G is equals to negative. For coming down, G is equals to what? G is equals to positive. For Earth, that value is 9.8 meter per second square or 10 meter per second square. So now join back the second meeting. We are going to derive that value and we have to see that what is the gravitational force for other planets.